Hi everybody, and welcome back to Unit and Unit Conversion. So this video is going to mainly focus on practice, and in the description below I have linked a Google Doc with the 4 practice problems, so please attempt them ahead of time before watching this video, as this video will serve as a key about how to solve these problems and about how to start the process. So for this first problem, a car travels through a tunnel at an average velocity of 15.2 meters per second. What is this velocity in miles per hour? We're given the information that 1 mile is equal to 5280 feet, and 1 meter is about equal to 3.28 feet. So here are some conversion factors that we'll actually be needing, and we'll actually be using here in a moment. But let's just figure out what answer we want our final unit to be in. And we know we want it to be in about miles per hour. Right now, we actually have it in 15.2 meters per second. So we want to convert from meters per second to miles per hour. So let's kind of lay out a little bit of a map here. Distances can relate very well, such as miles and meters, and that's what we were given here below, where we can given 1 mile is equal to 5,280 feet, and 1 meter is equal to 3.28 feet. So basically, with the meters, we can directly go to feet with the second conversion factor, and then we can go directly to miles with the first conversion factor. So there is 2 conversions that we have to do for meters. But we also want our answer to be in miles per hour, not miles per second when we convert our meters to miles. So we can kind of lay out the second row map where we have to convert from seconds to minutes and minutes to hours. So here we're actually going to have 4 different conversion factors that we'll be using within our fence table. So at this point, we have an idea of a roadmap of where to go within our fence table. In the previous video, I told you that you should really put the units that you want at the very end in the first or second column. And you don't have to do it this way. And from here on out, I'm not really going to do it that way. I'm usually going to do it with the information that we are given and then use the conversion factors in the following columns. It is all the same as long as the units that you don't want cancel out and the units that you do want retain. So to actually show that process, let's start our table. And actually, I'm going to put 15.2 meters per second here. And these are the units that we actually don't want, so we actually want to cancel them out. So we can cancel out meters because we actually want to go to miles eventually, where if we put our 1 meter on the bottom and 3.28 feet on top, because that is the only conversion factor that has meters within it. And so now our meters will cancel out and we'll be left with feet per second if we just stop the calculation now. But we want our answer to be in miles per hour. So we actually have to go from feet to miles. In order to do that, we'll use the first conversion factor, where there is 5280 feet in 1 mile. And then our feet cancel out. Now we're left in units of miles per second. But again, this is not the unit that we want in the very end. So now we know we can convert from seconds to hours very easily, as we've done in the previous video, where 60 seconds is equivalent to 1 minute, and 60 minutes is equivalent to 1 hour. And the reason why I put these fractions as I did with 60 on top, or 60 seconds and 1 minute on the bottom, and 60 minutes and 1 hour on the bottom is because this is the right orientation in order to cancel out our seconds and to cancel out our minutes in order to get a final unit of miles divided by hours, or miles per hour. And so the final answer here will actually be 15.2 times 3.82, or 3.28 times 60 divided by 5280. And after you do that calculation, you should get around 34 miles per hour. This next problem is asking the density of a solid is 4.28 grams per liter. How many grams are in 408 milliliters of the solid, knowing that there are 1,000 milliliters in 1 liter? So there's a lot of information here that is given. We're given that the density of a solid has about 4.28 grams for every liter of your solid. And this question is asking how many grams are there in 408 milliliters. Now, milliliters and liters will not cancel directly out, but there is a nice conversion factor where there is about 1,000 milliliters in 1 liter. And I'm going to write it as the equation sign, but this can also be written as a fraction in either direction with the 1,000 on top or 1 on top in that specific case. So this is actually all the information that we need in order to construct our table. So if we construct our table, I'm just going to start with, let's say, 4.28 grams per liter as our first entry. And again, the per liter will end up in the bottom, as that is the same thing as saying dividing by liters. But we want our final answer to be in grams, right? So we have to figure out a way to cancel liters. And again, we couldn't use directly 408 milliliters because those are not the same units. So we actually have the conversion factor to go from 1 liter to 1,000 milliliters. And we put it this way because our liters will cancel out on the top and the bottom. And now we're left with the units of grams per milliliter if we stop this here. But we want it to be in just grams, so we can cancel out milliliters with the other information given of 408 milliliters. And so if you do this calculation where you do 4.28 times 408, divide it all by 1,000 in the end, you should get an answer of around 1.75 grams if you round it to 3 significant figures in this specific case. All right, so problem 3 is actually talking about a problem that's not really chemistry or science related, but it can just show you how dimensional analysis can be used in everyday life, such as figuring out how many boxes of food to buy a pet. So in this problem, a pet is allowed to eat 100 grams of food per day. If each pack contains 250 grams of food and a box contains 6 packs, how many boxes does a pet owner need to buy to guarantee enough food for their new pet for a 30-day month? So there's a lot here. So anytime I start a problem with a lot of words, I write down everything that I can about the problem, and especially with the information with the numbers attached. So we're saying here, for one pet, it is allowed to eat 100 grams of food for 1 day. So it is totally fine to say 100 grams of food is equal to 1 day for this case, as this is our conversion factor that the problem gives us. If each pack of food contains 250 grams of food, you could say 1 pack is equal to 250 grams of food. And 1 box contains 6 packs. And the question is asking how many boxes does a pet owner need to buy to guarantee enough food for their new pet for a 30-day month. So we could just say 30 days in general here because we're only talking about 1 month in general. So here should be all the information that we need in order to get our final answer in boxes. Because we want our answer to be in unit of boxes, as that is what the problem is asking above. So the way that we can go through this problem is, in this case, let's just say I start with 1 box is equal to 6 packs in the first column. And I started with this because box will end up on top. And again, you don't have to do it this way, but this is just one way of doing it this specific method. And so we use the third line or the third conversion factor. But now we want to cancel out packs. And the other conversion factor that contains packs is the second one where there's 1 pack is equal to 250 grams. And now packs will cancel out. And so we're left with box per gram. Now, if we continue further, the only other conversion factor for grams is the first one where we say there's 100 grams for 1 day. And now our grams cancel out. And again, we don't want it to be in boxes per day. We just want it to be in boxes in general because we're talking about 1 30-day month. And so we can cancel out days by using the information of 30 days. And so if we cancel out our days, we're left with actually just an answer of boxes, which is the answer that we want our unit to be in. And so if you go out and multiply this through on the top and on the bottom, you'll get 3,000 on your numerator divided by 1500 in your denominator, which is just equal to 2 boxes. So this pet owner needs to buy 2 boxes of food for a 30-day month in order to feed their pet. All right, for our last problem here, this could be more of a chemistry-based question, as a lot of the conversion and dimensional analysis is a lot in the chemistry courses that I've seen throughout my undergrad and graduate school career. So, an isotope of atomic carbon has a mass of 13 atomic mass units for every atom. If there is 1.66 times 10 to the negative 27 kilograms in one atomic mass unit, how many kilograms are there in this amount of atoms of carbon-13? So, here's a lot more information and just more scientific-based information. But if you don't remember any specific equation, 99% of the time dimensional analysis will help you get your right answer. So in this specific case here, we're told that an isotope of atomic carbon has a mass of 13 AMU, or atomic mass units, for every atom. I'm going to say one C13 atom, because that's what we're going to be talking about here. And now, it's talking about how many kilograms there are in 1 AMU. So 1 AMU is also equal to 1.66 times 10 to the minus 27. And there will be a future video about scientific notation, but there's an easy way to plug this in your calculator with 10 to the power of negative 27 as well. And the question is asking how many kilograms are there in about 1.5 times 10 to the 23rd atoms of C13, or C13 atoms. So really, this is all the information that we need to construct our table in order to cancel out to be left with kilograms, because that's our final answer that we want our unit to be in. So if we construct our table again, let's start with the 1.66 times 10 to the minus 27 kilograms divided by 1 AMU. And the other information with AMU in this problem is that there is 13 AMU for 1 C13 atom, and our AMU unit will cancel out. And so we need to cancel out C13 atom, and we can do that with our third piece of information, that there is 1.5 times 10 to the 23rd C13 atoms. And so when you actually go through and multiply this out on top and divide it by 1 on the bottom, you will see that there's around 0.0032 kilograms in this amount of C13 atoms. I hope you like this video. If you need extra practice or want to talk through any of these problems in the comments, please let me know. I hope you all have a great day and keep writing your units.